All right, welcome everybody. We're gonna do a little bit of blueprints, and then we're gonna move on to Water Week. So we're gonna be talking about all things water this week, but there is one little addition that I want to add to our goalkeeper over here, so that if we kick the ball under the goalkeeper, it plays a different animation rather than just hovering in space like it does currently. So if we pull this out here and we drag the skeletal mesh out here, there is a blueprint node called Play Animation, and you can choose one of the animations to play when the player hits it out of bounds. And jogging, T-posing, ooh, that foot animation. I don't know. It would be something funny, idle, run, walk, falling. And we'll just use the jump one. That's what I did before. And then we'll wait for 2 seconds, and then we will put it back onto the default animation, which is fall loop. Drag this out to here. Double click to get a reroute node. Come on. Come on. Thank you. This is fall loop here. And we'll put that on loop. Why not? Okay. So if we save it and compile it and run it, then if I kick the ball out of bounds, it plays an animation for 2 seconds and then stops. And the ball goes out of bounds, and I can kick it through again. And you can see it plays whatever animation we have. So we can have it do like a catching animation or kicking animation or something like that. Either way, that's just a little fun node for you guys to play with. That is called Play Animation. You can drag out a skeletal mesh and choose any of the animations associated with it. Maybe, oh, that could be hilarious. Its calf is gonna run around in circles, which is gonna look absolutely ridiculous and stupid, but I want to see this. Nope, no, I scored. Ah! Why must I fix everything I touch? Absolutely dumb. Absolutely dumb, and I love it, so I'm going to keep that. All right. So yeah, play animation. Any skeletal mesh that has use animation asset on it, you can just pick a different animation. You can kind of hard code animations that way. So you can play one animation or another, looping or not, your choice. All right. So moving on to Water Week. So over here we've got our water plane. If you remember, we took the ocean material and we made a new one that had a much higher tiling value on it, so it wasn't all stretched out all to hell. It's properly tiled. But when we walk through here, it doesn't really look like we're underwater very much, right? Like this is dark, I guess, but it's not. It doesn't really give us the feeling of like being underwater. So let's go to the details panel here and water ocean. It has no collision. Okay, so we'll fall through it currently. So what we're going to do is we are going to add a physics volume to this. There are different volumes that are in Unreal Engine. Some of the more useful ones include things like a blocking volume. A blocking volume is anytime you've had a invisible wall in a video game where you like, what did I do there? Anytime you're like trying to walk to an area you're not supposed to walk to, and you just like face plant into an invisible wall, that's something called a blocking volume, and it's vanishing. I don't know why can I not see this thing. Blocking volume. It vanishes. Where is it? Oh, weird. It's appearing up there. Okay. Oh, strange. Let's come over here. And if we just want to be mean to the players that are going to be trying to get to that boat, we can just throw a little blocking volume here, scale it out. And then if we try running over to that boat, we're going to just face plant into the invisible barrier there. I don't have sprint yet. Okay, so we come over here. You can't see anything, right? These volumes are all invisible. You can see them in the editor, but if you try to run through it, you can't. You could maybe jump over it. Maybe jump on top of it, right? So these are very commonly used in video games, especially when you just have like sort of like an edge of the world. You just don't want players like running off into the distance, getting lost, and things like that. People will just put up blocking volumes and just stop them from escaping. But we're going to do a volume called a physics volume here. And is this going to vanish again? Yes, it did. Why is it appearing way up there? I don't know. Okay, so we are going to do a physics volume, and I'm going to move it just below the surface of the water, and I'm going to scale it out to encompass the entire underground area. This. Okay. Alright, that's under the surface, it doesn't matter. And I'm going to widen it out. And that should be pretty good, I think. Yeah, I might need to make it a little bit taller. Yep. So now we've got this underwater area. It is a physics volume, and so what physics volumes allow you to do is they allow you to change physics within that zone. So all of the volumes sort of say, in this zone, something different is going to happen, right? Like in a pain-causing volume, you can do damage to the player every second they stand within the lava or the fire or whatever. But in a post-process volume, you can change how the camera behaves within that volume. A physics volume changes how physics operates within that zone. So for example, you could make it water, which is what we're doing. Okay. And so by just checking one box, and we can look at the other things, but we're not gonna. By just checking that one box, what happens is we have now said that zone is water. And so when the player enters it, it's going to automatically switch them from walking mode, which is your standard movement mode in this template at least. It'll switch us into swimming mode. So if I can get down here, you can see I'm not touching anything right now. I am just swimming. Is there a swim animation? No. Can you add a swim animation? Yeah, absolutely. But by default, you are just, that is the default swim physics inside of Unreal Engine. Is it super nice? No, not really. Can I press backwards? Can I stop? Kind of. There's like a lot of water friction. Can I jump to swim up? Nope. I'm hitting jump. I want to swim up. I can't. You have to build all that in yourself. But it's a starting point at least. Yeah. If you want to edit your swim settings, if you come over to the BP third-person blueprint, BP third-person character rather, if you click on, if you open up, remember this is like the main for your program. If you, instead of your BP third-person character, there is something called a movement component. There it is, character movement. I don't know why I couldn't see that. Okay, so you have a movement component here. And if you look at these, there are different settings for the different types of movement that you have. If you want to walk faster in the game, which I do, so we haven't done sprinting yet, I am going to double my walk speed. So I'm going to take it up to 1,000 centimeters per second because I'm tired of walking slowly. Can you walk off a ledge? Can you crouch? How tall are you when you crouch? How steep a hill you can climb up? How much friction there is on the ground. All these things you can set. They're also controllable from blueprints. So maybe we have time today maybe with time today we can do a sprint system as well. We'll see. But what I'm looking for here is not jumping, falling. I'm not looking for flying. I'm looking for swimming. And so if you want to add extra buoyancy so you bob up to the surface, you can do so here. And you do a huge buoyancy of 10. Compile, save. Again, this is within BP third person character. Under character movement, under the swimming tab here. And there's different tabs for flying, walking, jumping, etc., etc. Okay, and if you notice, I'm now walking a lot faster than before. Yay, nice. If I come in here, see how I'm bobbing back up to the surface with all that. It looks terrible, doesn't it? Boing. So all that buoyancy is launching me out of the water, and then gravity is pulling me back in. So it looks terrible. So maybe we'll do a buoyancy of like 2. One of the best bugs I've ever written in a video game was I set effectively buoyancy too high, and it catapulted me up out of the water to the effect that it worked kind of like a trampoline. And I called it Jello water, and I kept it. Like, I kept it as a server setting where servers could enable it, and it's a lot of fun. It actually changes maps quite substantially because you can run and jump and bounce off the water, and like a giant trampoline, and everyone's like bouncing on the water. It's actually a lot of fun. It really is. So that is a physics volume. So I've put a physics volume underneath here. I've got water turned on. The player, I turned up the buoyancy so they kind of bounce up out of the water a little bit. And yeah, that's fine, I guess. I might tone it down just a little bit more, because it's still kind of doing this, cyclic kind of thing here. The max out of water step height, that's actually kind of important. Valheim is a game that doesn't have a out of water step height set properly. I don't think it's set at all. What that means is if you come to a lip, like you're swimming in a swimming pool, and you're swimming in the game, you come to like the edge of the swimming pool where like, you like hang on to it and stuff like that. In a lot of video games, you can dolphin up out of the water, and you can pop up out of the water. In Valheim, you can't. And so if you're in Valheim and there's like a staircase in front of you and you're in the water, you actually can't get out of the water because there's no out of water step height. And so what you have to do is you have to hope that there is waves that will raise up and lower down, and then as you bob up, you walk over on top of the staircase, and then you can climb out. Otherwise, you just bump into the side of the stairs, and there's nothing you can do about it. If the water's perfectly calm, you're just like, well, somebody get a boat and come get me. It kind of sucks. So you usually want these set fairly generously. Out of water Z is the porpoise effect. Like when you get up out of water, it kind of boosts you upwards a little bit. We can make this 10 times stronger. See if we do a little Jello water effect with that. See if I can dive off the diving board here. Nope. Not nearly as big as I was hoping it would be. Just a little kick. All right. Yeah, good enough. Okay, so this is kind of like where your movement settings are found. You can switch. There's ways of switching the movement. Like you could switch the character to flying if you want. That could be kind of fun. You can sprint. All these kinds of things can be done in code. There's one other volume, though, that I want to show you guys today for the underwater effects. And that is, and if I'm going to do this, I'm going to need to turn buoyancy off. Release back down. And that is something called a post-process volume. So if you drag out the post-process volume, and it went up again, it's so weird. Again, I'm going to cover this whole underwater area here. So just moving the box until it vanishes. This way. Get it from the side. It's good enough, I think. Almost. And so what a post-process volume does is that it messes with the color and the camera settings and things like that. So you can add film grain. You can make the world go out of focus here, like I just did on my webcam. So you don't have to put a post-process volume underwater. Like I could make it so I'm permanently blurred. I don't know why the webcam always does this, by the way. It just absolutely refuses to focus once I adjust where I'm sitting. Like I could come over here and add a post-process volume, right, I don't know, here, a little bigger, bigger. And then all of these options here, like there's just crazy amounts of options. Depth of field, chromatic aberration. Camera inside of here. Turn that on and drag that up. See the chromatic aberration effect there. Basically, this simulates light going through a prism, and higher frequency light bends more through a medium like glass and things like that. So you'll see chromatic aberration on things like a sniper scope and things like that in a lot of video games. And so a lot of times they kind of do just a little bit of that effect. So you can see like there's a red thing here. I always turn it off. Like it bugs the hell out of me. I'm still blurred. Look at this. That's in focus. Now focus on me. Now focus on me. No. There we go. It worked. Just have to say please, maybe. I don't know. Exposure. You can have the world become a bright place. Watch. You walk in. You are now entering heaven, right? Kind of cool. You can have dirt applied to the screen, or watermarks and things like that. You can adjust the ISO. And it's not letting me change that. Exposure, lens flare, depth of field. So you mess with the depth of field on things. Color. You can have the world become more red, or here's the thing for your assignment. Here's normal. Here's inside of the post-process volume. You're getting close. It's getting hot when you're, for the underwater zone over here, what you can do is make it more blue, right? Because typically when you're in an underwater zone, post-process volume 3, world settings, outliner, post-process volume 2, Control-Shift-S, by the way. Okay, so down here we are going to go to, so when we are underneath the water here, we want it to take on kind of a blue tint. And so I'm going to set temperature, and I'm going to drag it up and down, and you can see that looks like I'm kind of underwater now, right? So when I'm up, and I'm underwater, kind of gives it a little bit of that feel. Tint. Blue. Looks kind of terrible. There you go. So, what I'd like for you guys to do is mess with the post-process settings and create a cool little, underwater effect. Do film grain somewhere within here. Let's see, grain, film grain intensity, shadows, materials, highlights. Drag it up. I don't know if this is coming through on the stream, but there's like little dots, flashing on the screen, and that can simulate, lack of oxygen and things like that. So, yeah. So basically, while you're underwater, you get this like sparkly, post-processing effect, and then we're up here, everything's fine. And then if you enter the area right in front of the goal, the screen turns kind of red, like, oh, it's very exciting, and maybe we can, maybe we can bloom. This. So the lights are like more bloomy. See that? You get like this. It's like the halos you see on streetlights late at night. You come up. It's like, wow. You know, it's very exciting. You're so close to the end zone. You can almost taste it. You know, if I play the game, what's cool is that the editor will actually show you the camera effects you're getting. So if I come up here, you can see it does the all the cameras within it. Got super bloom, it's super red. And then when the camera moves out, I need to make the zone bigger, I guess. Make it worthwhile, but looks pretty cool, right? It's pretty cool. Watana, McKinney, Chua, you guys have any questions about post-process volumes and things like that? Look at how bloomy that sun is, right? Get into that bloom zone. It just blooms right out. It's a blooming onion from... It's so ridiculous. All right now? All right. Let's see if I can score a goal. Yay. All right. And then when I come over here to the underwater zone, you see everything turns blue. There's a film effect. And that's your homework for today. All right. So add a... oh, it's still scoring. I'm at -6 points. -7 points. -8 points. That's so stupid. Okay. Let's get some points back. There we go. So that's basically what your goal is for today. So create that underwater zone and maybe add some decorations, add some kelp, add some mermaids, seashells, I don't know. Make it look nice. If you want, we can Outback. Yeah, the bloomin' onions from Outback. 2,000 calorie appetizer. Right? We could make this a little more interesting. One of the tricks that I learned when I started in the industry was that if you move a plane of water like this up and down a little bit, it looks like the waves are coming in and out. It's kind of cool. So, especially when you have when you have a kind of an interesting contoured landscape like this, we just kind of move it up a little bit. You can see it's like the waves are kind of rolling in and out. So we will turn this plane of water here, this plane, into a blueprint, and we'll do that by clicking here. And we will call this water plane BP. And I'm going to put this into the build directory. Save. So there's a preview of our water. Now, I'm going to show you guys how to do some simple animations with this. It's today's water day, so having water animate is kind of cool. So overlap, don't care about you, but we do care about begin play, and we do care about event tick. So the first thing we're going to do is we're going to write down our starting location. Because what we're going to be doing is we're going to be moving our plane up a little bit, we're going to be moving our plane down a little bit, and we always want to be able to come back to our starting location, because if you just kind of like add to the vertical and subtract out of the vertical, eventually the math will kind of accumulate errors, and the plane might start rising up out of the world and things like that, or it might sink down into the world. So it's always important to save your starting location. So let's drag out from here. Actually, we can just do get actor location like that. And a good shortcut for making a new variable is to right click on it and choose promote to variable. Like that. And so what that'll do is create a new variable of the right type. Cue to line these things up. And the new variable, I'm going to give it a name called starting position. So that is going to write down, essentially we're going to say we started at x equals 10, y equals 20, z equals 30 or whatever. You know, it's going to write it down, and we're going to use this as a reference to kind of flow up and down over time. So what we're going to do is every frame we're going to animate this. We could use a timeline. There's different ways you can do animations. I'm going to do the worst way of doing it. How about that? So what I'm going to do is I'm going to get the time. Get time of day, get second, get month, get minute, get millisecond, get day of year. Good day. Good days, total seconds. Yeah, sure. All right. So, nope, that's not it. Get time of day. Okay. Nope, that's not it either. Get time, get simulation, time, get time of day since midnight of A. Span, get accumulated time. What is this? It's just standard get seconds. Get hour, get month, get seconds. Get game time since creation. Yeah, I don't know. Okay. All right. So, cool. All right. All right. So what we're gonna do? This is gonna tell us it's been 1 second since we've been made. It's been 2 seconds since we've been made. It's been 3 seconds since we've been made. And what we're gonna do is we are going to use this to animate the wave, essentially the waves up and down. So, if you guys have ever not had trigonometry, this might not mean anything to you. But we are going to do sine and radians. Why not? So every 6 seconds, it's going to go up and it's going to go down. We can affect this with multiply, maybe. And this guy here, we are going to promote to a variable. Let's see if I can line these things up right. And this variable is going to be called frequency. So if we set frequency to like 2, then it'll the water will go up and down twice as fast. So we're just going to leave it at 1 by default. And then the result of this, we're going to multiply by another float. This other float, we're also going to promote to a variable. And this variable is going to be called amplitude. And that's how big the waves are going to be. By default, it's going to move up and down a centimeter, which is not very much. And so we need to set amplitude to some large-ish number, like 200. And so that'll move it up and down 2 meters. It might be too much, who knows? We could also do a phase on there. If you guys haven't taken trig, this doesn't mean anything to you. But basically, if we turn frequency up, the water is going to go up and down faster. If we turn amplitude up, it's going to go up and down higher amounts. So frequency is how quickly it vibrates. You can have a low frequency wave. You can have a high frequency wave with the same amplitude. You can have a big amplitude, or you can have a little small amplitude. So you could have phase offset. That makes absolutely no difference, though, for a situation like this. And so what we're going to do is we are going to set our location. So we're going to do set actor location. So we're going to set our location to be our starting location, starting position, plus, actually we're going to split this open. So we're going to get the X, Y, and Z. We're going to split this one open. And let's see if we can make room inside of here. This X connects to X, Y connects to Y. We don't want our ocean sliding sideways at all. All we want it doing is moving up and down. And so what we're going to do is get the X. It's not lined up anymore. We're going to get the Z position, and we are going to add to it this value here. Let's see if I can line these things up. There we go. Okay. So basically, we're going to get our starting position, and then every frame, that's what event tick means. Every frame, we're going to update the position of the water using using the current time. So currently, every 6 seconds, it's going to move up 2 meters, and it's going to move down 2 meters. And, are we set to be movable? That is a good question. No, we're set to be static. Okay, so watch what happens when I try running this code. Watch what happens when I try running this code. Static, remember, static means it can't move. And I'm trying to move it. So watch what happens. You guys see it moving at all? Yeah, no? No, it's not moving. And we get tons of error messages. Basically saying you need to set this to movable if you want it to move. Okay, so we're going to click on that. We're going to come back into water plane here. I'm going to change this to movable. And if that doesn't fix it, we might have to set other things to movable. That should do it. Yep. And you can see here that the water is moving a little bit too much, I think. But there we go. So every 6 seconds, it is moving up and down 2 meters. And it's sort of violating the illusion because you can actually see that the plane is rising up and down now. So I'm going to turn the amplitude down to maybe 1/3 of a meter, 30 centimeters. And then it should maintain the illusion that it is actually water running in and running out. So you come in and look at it here. You can see it's following the contours of the lake. Coming in, going out. And that actually looks pretty good, honestly. Now it's flooding the boat. That's actually pretty dramatic there. Oh yeah, that's actually violating the the illusion as well. I might even turn it down even more. And I might move it down a little bit more too, because right now it's flooding the bottom of the boat, which looks really good. Yeah, looks pretty good. Maybe even still a little bit too dramatic. Turn it down even more. I don't know why I'm whispering. What do you guys think of this? McKinney, Watana, Chua, what do you guys think? Yep. It's definitely fun to work with. Is this like right at the edge of the plane? No, I guess not. It's just a flat surface. Okay. So that is our lecture for today. So this is a very quick and dirty way of doing animations. Basically, every frame we figure out what location we should be at. I don't recommend doing animations this way because it's something that runs. It's doing trig every frame. If you have a lot of objects in the world that are all doing things every frame, it'll slow you down, but we've got one, so who cares? But there's other ways of doing animations that are better than this. But just to re-explain everything, what happens is that when the world begins, when the game begins, we save our location into a variable. And then every frame, we are getting our location here, our starting location here. And we're going to add to the z value. So we're going to move up a little bit. We're going to move down a little bit using the powers of trigonometry under our belt. If you don't understand trigonometry, just copy this. Make sure you set frequency to 1. The most common mistake I see with students is when you make a variable, the default value is 0. And if you set a frequency of 0, it won't animate, right? Because time times 0 is always 0 and it won't move. So make sure, and like when you make a variable, right? Let's make it float. You can't even set the default value over here. So a lot of students just miss this. You have to compile it, and then the default value will appear, and then you can set it to 1, and then make sure you compile it and save it again. So the most common mistake I see is they set frequency to 0, then it won't animate. If you set amplitude to 0, it won't animate. Why? Because how much does it move up and down? 0. So you're doing all this effort to essentially add 0 to the z-axis every frame, which is completely pointless. So make sure that you got good values in amplitude and frequency. I like starting off with my amplitude fairly dramatic, because if you start off with amplitude at like 1, then you really have to get close to the water and be like, is that moving a centimeter? I can't really tell. You know, so I usually set my things to be pretty dramatic. So it's like going like this. And I'm like, okay, it's working, you know? Because if it's not moving, it could be other things. It could be the fact that your static mesh is set to be static right here, right? Static mobility. If your thing's not moving, that's another problem. If it's set to static, the thing cannot move. And if you're trying to move it, then you're destined for failure. Fortunately, the engine will warn you you're trying to move a static object. Please set it to movable. And so that at least you get a nice little error message on. I do it all the time. I forget to set things to movable all the time. It's just one of those things. And I see the error. I'm like, yeah, okay, I'll fix it. So that's it for today. I will see you guys on Thursday. Peace out.